Yes, welcome back all of you. So in last class we observed that what is MTI and pulse Doppler radar simply, and we have seen how to estimate or how to separate the moving targets from the fixed targets with the help of the A-scope display and also PPI. Okay. Now today let us discuss about the block diagram of MTA radar with power amplifier transmitter Okay. So see the block diagram and what are the different blocks it includes. Okay. How the reference signal will be derived in this power amplifier transmitter case. Okay. So this is the diagram of MTA radar using power amplifier transmitter. Okay, the various blocks involved here are with reference to transmitter. With reference to transmitter, the main blocks already we know from the antenna. We can take it as duplexer, the duplexer unit, and power amplifier, pulse modulator, power amplifier and pulse modulator. Of course, some blocks are connected to both transmitter and receiver. So that is mixer, this mixer, and these are the two types of oscillators. One is the Coho oscillator and another one is Tallow oscillator here represented, but their full names are coherent oscillator. It is a very stable oscillator. Okay, coherent oscillator and very stable oscillator. Okay. So compared to previous block diagrams, actually here the difference with this is the generation of the reference signal. Okay, in the generation of reference signal, you have the difference. Okay, so here the reference signal is generated by an oscillator named as coherent oscillator with the frequency Fc, and another oscillator is a shallow oscillator or a stable oscillator named as with the frequency Fl. So these two oscillators output are connected to the mixer shown here. This is the mixer mixes these two frequency signals so that the output of the mixer is Fl plus Fc. Okay, Fl plus Fc, and this is the frequency of the transmitted signal. So in previous diagrams case, we have the separate transmitter generator is there, but here whatever the stable oscillator is used and coherent oscillator is used, these two decides the frequency of the transmitting signal. Okay. So after that signal is amplified with reference to power using this power amplifier, and at the same time, the output of the power amplifier will be a pulse type of wave, because the power amplifier is switched on and off by the pulse modulating unit or pulse modulator. Okay, the pulse modulator decides when will the power amplifier will amplify and when will it stops the amplification. Okay, it stops the amplification means no signal coming out from the amplifier. Okay, so that the signal Fl plus Fc is converted into the pulses. Then the output of the amplifier consisting a signal of a pulse type of signal with a frequency Fl plus Fc, and it is connected to antenna through a duplexer unit. The antenna radiates it in the direction of the target. Okay, but here only one antenna is used for transmitting and receiving. Okay, that possibility we can have because with the help of the duplexer. So that using duplexer, only one antenna is enough for actions like transmitting and receiving. No need to use two separate antennas, one for transmitting and one for receiving. Okay, so the duplexer determines when the antenna has to act as a transmitter and when it has to be act as a receiver. Okay, then when the signal is received, or collected by the receiving antenna, and duplexer applies this echo signal to the receiver mixer. This is the receiver mixer. Okay, and the echo signal, with the frequency of transmitting signal. Suppose if the target is a moving target, the frequency shift is added, referred as the Doppler frequency shift. Okay, so therefore the echo signal frequency is FL plus FC plus or minus FT. That much is the frequency of the echo signal connected to the mixer. So for this receiver mixer, the reference signal is from the stable oscillator, that is FL, so that the output of the mixer will be FC plus or minus FT. FC plus or minus FT. And then it is amplified by the IF amplifier, followed by mixer. You have the IF amplifier, it amplifies the signal. Then a phase detector is there, used to separate the Doppler frequency shift from the output of the IF amplifier by taking coherence oscillator output as a reference signal. So that the phase detector output is the only Doppler frequency shift, and which is then connected to the delay line cancellor. After that, what are the blocks and how it gives the output to the I-scope display or PPI. In PPI case, generally these delay line cancellors are used. Okay, so this is the operation of MTI radar with the power amplifier technique. How it extracts the Doppler frequency shift from the echo signal frequency, which is equal to sum of the transmitted signal frequency and the Doppler frequency shift. Okay, so that after knowing the FD, you can calculate the velocity, the speed with which the target is moving. Next class, we can see the same MTI radar block diagram, but with oscillator concept, right?